Welcome to this session on loops and iterations. I'm Dr. Shahan Pura from the Department of Computer Science and Engineering, University of Moratuwa. At the end of this session, you will be able to see what is a loop, how we can use a loop to iterate or repeat, why we need loops, and how we can solve problems using loops. We will be using the standard color. We will discuss why we need loops and how we can use two different types of loops that are available in Python when writing code. Also, we will look at how we can put a loop inside another loop or multiple number of loops together. And also, we will look at how we can use some of the keywords that are available in Python to change the normal way of a loop working. At the end of the session, we will be able to write code in Python that has repetition and also know how you can use repetition and iteration to solve problems. Let's look at why we need to repeat or iterate. Let's assume that you have the marks of a student and you want to find out whether the student has passed or failed. If the student has more than 50 marks, you will say pass. Otherwise, you won't say anything else. For one student, it's okay. Let's assume now that we have 5 students. How do we do that? One way of doing that based on what you know up to now is to copy the same code 5 times and put it on a Python program and execute. You will be able to do it for 5 students. Is this the best way of doing it? Is there any other way so that we can take the block of code doing the work for us and get it to repeat 5 times? That is why we need repetition and iteration. If it is 5 students, it's not a problem. But if you have about million or 100,000 students, then it's going to be a problem to just copy and paste the code and try to do repetition by sequence. We already know that we can use sequence to go through a sequence of code in a program. We also looked at how we can decide which way to go based on a condition. If the condition is true, we go in a different direction, and if it is false, we will go on another direction. Today we are going to look at how we can use repetition or iteration in the code. Now let us look at how it works. We have 5 grades in a list and we want to print the grades. We start with the student 1 or the list item 0, and we want to repeat this 5 times. So a way of giving the condition is to say that as long as the student is less than 5, continue this loop. And we also need to make sure that we put the print statement. We have the print grades. And also not only that, we need to make sure that the student index or the number is increased by 1 at each iteration, so that when we go to the next iteration, we'll be taking the next student. So we need to put that. This is how the iteration works. When writing code, some parts of the code needs to be repeated multiple times. In certain cases, we may know how many times we want to repeat. In certain other cases, we may not know, and we may be required to check for a condition. And until the condition is satisfied or true, we want to repeat the block of code that we have. When controlling the flow of the program, and we want to iterate, one way of doing it is, as we looked at earlier, copying the code, which is a very inefficient way of doing. So, like many other programs in Python, we have 2 ways of repeating, the for loop and the while loop. First, let's look at the for loop. In the for loop, the block of code is repeated or iterated a specific number of times. The format of the code or the syntax of the code is to have the for keyword and tell that for each iterating variable in the sequence, loop through the code or the block of code. For and in are the 2 keywords, and the iterating variable and the sequence are variables that we define. The sequence can be a list of numbers from where each time the iterating variable will be taking an item, starting from the first one until it reaches the end of the list. And we also have a colon at the end. Don't forget the colon. If you forget, you will get a syntax error. Then we have the block of statements that are part of the for loop. And this block of statements or the code is called the loop body. And this has to be indented so that the code knows that this is the part of the code or the block of code that belongs to this loop. Now let us look at an example. In this example, we have a for loop The iterating variable is the counter, and we have a list of numbers that go from 1 to 5, so that the loop body will be executed for each number that we have. We also have a print statement. If you look at when it executes, how it would work, we see that each iteration we will get a print line getting executed for 1, 2, 3, 4, and 5. Also, we can note that we have only one print statement in the code, but we have got the print statement executed 5 times because we have put it inside a loop. It may be not practical for us to type the sequence of items that we want the iterating variable to take. So we have the range function to create a sequence of numbers as we want. One way of indicating the range function is to give when you want to stop the sequence. So if we give 10, the sequence will have 10 items, and the sequence will start from 0 and go up to 0. If you don't want to start from 0, we can indicate the starting point. In this example, we say start at 5 and then stop at 10. So 5, 6, 7, 8, 9 will be printed. We can also have a situation where if you don't want to increment by 1, we can say how you want to step through or how you want to increase the number of the item. So if you give it like this, where we say start at 0 and then stop at 10 and also increment by 3, we will get a sequence where we have 0, 3, 6, and 9. We can also start with negative numbers. We can also increment by using negative. All sorts of combinations are possible with the range function. I'm not sure when you were small and in school, you got punished for throwing paper inside the classroom. One day this happened to one guy, and the teacher asked him to write, "I will not throw paper in the classroom 500 times. So what does this guy do? Next day he goes to the school with these 2 lines of code. I will leave it up to your imagination to think about what happened next. Okay, let's look at another example. Let's say that we want to sum all the even numbers between 0 and 100, including 100. You might think that you can do that with one single line of code using a formula. But to learn for loops, let's look at how we can do it with a for loop. First of all, we need to have a place to keep the total of numbers that we are going to generate. And also we have to make sure that it's 0 so that we don't have anything else in that variable that we are going to use to collect all the even numbers. Next, we need to put a for loop. In this for loop, we need to have an iterating variable. So we say counter as the iterating variable. And also we need to generate the numbers or the even numbers. We need to start at 0 and we need to stop at 101 because we want 100 also to be part of this sequence of numbers that we're generating. And since we want to have even numbers, we need to say to step by 2 so that we get all the even numbers. Inside this loop, now we have indented this line because it is part of the for loop. We need to make sure that the total is equal to the counter, the values that we get to counter in each iteration. So we say total equals total plus a counter. Now we are done. Once we finish this loop, we need to make sure that we print the total. So we have a line called print total so that we can print the total of even numbers between 0 and 100. Remember, we need to make sure that the print statement is aligned with the for because it is not part of the for loop. We only want to print it after we finish the loop. We also have another type of loop called the while loop. In the while loop, the block of code that we give as part of the while loop will be executed until the condition that we give is true. That is why we call it the while loop. While the condition is true, continue to execute the block of code that we have given under that loop. The format of the while loop is very straightforward. We have the while keyword, and then we have a condition, and we have a colon. Don't forget the colon, because if you forget the colon, you will get a syntax error. And after that, we have the statement or the statement of code that we want to be executed as part of the while loop. Once again, we need to make sure that the statement is indented. And we call this block of statement the body of the loop. And it's up to the programmer to take care of initiating how this loop is executed. In other words, it's up to the programmer to give a condition to check for the while loop to be continued, and also it is up to the programmer to ensure that this condition is made false at some point in time so that this while loop can stop. Otherwise, we will end up having an infinite loop. Here is another example for the while loop. Let's assume that we want to print hello world a number of times based on the number the user inputs. So at first, we have a line of code where we ask the user to enter the number of times you want or he wants the hello world to be repeated. And we need to have a loop. We are using a while loop. We can do this using a for loop, but for us to understand how to write a while loop, we'll use a while loop here. We have the while keyword. We have the condition that we say number is not, we want this to be continued until the number is not equal to 0, and also we have the colon. Then we have the line of code to print the hello world, and we can't stop there. With a for loop, we can stop there, but with a while loop, we need to make sure that we reduce the number by 1 so that sometime it will become equal to 0 so that we can exit this while loop. Then we finish off the code and we put an end. Let us look at when we execute the code, what happens and how it is executed. In this code visualizer, we have an area to show the code, and also we have a red arrow to indicate which line of code is being executed, and we have an area to see the output where the output will appear, and also we have an area that would show us the variables and the values that the variables are changing. For example, we have a variable called num, therefore the num will appear here and also show us as it's executed how the num is changing. Now let us see what happens when we execute this code. In the first statement, we have an input statement asking the user to put an input, and that value will be put to num, the variable name num. And in this example, we are inputting 5 as the number, and then we will come to the statement or the while condition. The while condition will be checked to see whether the num is not equal to 0. At the moment, num is equal to 5. Therefore, the condition is true. Therefore, we will go to the iteration or the first statement in the loop block. We have a print statement saying hello world, and that when we execute that, we see that the output is coming as hello world. And then we have a statement to reduce the number by 1. And when you execute that, we see that the variable num now has changed to 4. And we once again go back to the top of the while loop to check the condition again, to check and see whether it's true. The number is equal to 4, therefore the condition is true. Therefore, we will execute one more iteration of the print, and we will be printing hello world. And once again, we will reduce the number by 1 and go back again to the top of the loop to check the condition. Check condition is true because the number is 3. Again, we will print hello world. We will reduce the number by 1 and again check the condition. Print hello world. Reduce the number by 1. Again, go back to the top of the loop, check the condition. Now the number is 1. Still the condition is true. Therefore, we'll execute. Now the number becomes 0. And when we check the condition, we see that the condition is not true anymore because the number is equal to 0. Therefore, it will exit the loop and go to the last statement in this code and print the end and finish the execution. User enters -5. This number will never become 0, or this condition will never become false. So that is why it is very, very important for the programmer to make sure that he puts a condition that will become false so that we can get out of this while loop, or the code can get out of this while loop. And also the variables and how we change the variables is carefully designed so that the condition at some point of time will become false. Now that we know two types of loops, what is the difference? In most cases, we can use either the for loop or the while loop to do the same thing. But in general, a guideline is to use the for loop when we know the number of iterations or the set of iterations that we need to do at the time of writing the code, and use the while loop for all other cases. Remember, we have to take care of the iteration in a while loop. Therefore, it would be much safer to use the for loop whenever we can use the for loop. And in cases we cannot use the for loop, go ahead and use the while loop. We can also have nested loops. We can put a loop inside a loop to make a nested loop. The syntax is as given, where we indent the loop inside the outer loop. When we execute for each iteration of the outer loop, the entire inner loop will be iterated. Once it finishes, it will go to the outer loop and take the next iterating variable from the outer loop, and once again completely execute the inner loop iteration. We call it the nested loop because we are putting a loop inside another loop. We can have any number of loops inside the loop. For example, we can have loop inside a loop inside a loop. Note, if each loop is long, it will take a long time to finish all the iterations of the loops that we have put inside or nested. We can also have other combinations. In the previous example, we had a for and a while, but we can also have a while and a for, or a for and a for, while and a while, or any number of iterations. So any combination of nested loops is possible with any number of loops inside a loop. Let's look at another example where we would want to print this set of characters. You might think that you can do this with one print line using Python code, but let's do this to learn how to do nested loops and use two for loops nested in each other. How do you develop the code for this? First of all, we need to come up with getting one single line of characters printed. How can we do that? We can do that by having a for loop that goes from 0 to 10, because we have 10 characters to be printed, and also having a print statement, one print statement to print one single character. If you execute this, what will happen is we will be able to get $10 signs printed. Now, this is not enough. We need to make sure that once we finish printing $10 sign characters, we stop and go to the next line. So we put a print line, and we don't put it with as part of the for loop. Now that we have one line of dollar characters, and we have also put a print statement to make sure that we go to the next line, we need to print 5 lines of these dollar signs. How can we do that? To do that, we can put another for loop outside this inner loop, where we say it for x to go from 0 to 5, so that we can get 5 lines of the $10 characters printed as we want. And when we execute this, what will happen is it will print the 5 lines of dollar characters that we want printed. We also have a few options to get the code to execute slightly different to the normal execution of a for loop or iterating through the loop. Sometimes this can help us to write code with loops and do slightly different things. For that, we have 3 different keywords: the break, continue, and pass in Python. Let's look at these with a few examples. The break statement or the break keyword is used to exit the loop suddenly without completing the loop. When the execution comes to the break statement, what it will do is it will go to the next line of code that is immediately after the block of code that we have for the loop. A break statement should always be put inside a if condition. If we do not put it inside a if condition, what will happen is it will always get out of the loop when it encounters a break statement, and the rest of the iteration will not be executed at all. That is why it is very important for us to put a condition, check the condition, and when the condition is true, only when we want to break, we break. If you look at this example, we have code that is printing hello world, including the number of the iteration, and we are asking the loop to break if it finds number 3 or the I is equal to 3. It will also print count is aborted and break after that. When we execute this code, it will go through the first 3 iterations, and when it comes to the 4th iteration where I becomes 3, it will print count is aborted and break and get out of the loop and complete the code execution by printing end of program. Continue is another keyword that we have used inside a loop to skip the rest of the loop body in the current iteration. It will continue with the next iteration of the loop without executing rest of the code that we have below the continue statement. Used to jump to the loop control statement when we want. If we have a need to jump back to the control statement or the condition, we can use the continue. The loop condition will be evaluated and the next iteration will continue. And once again, a continue statement within a loop should always be put inside a if, similar to what we did with the break. Otherwise, what will happen is it will always continue when it reaches the continue statement without executing the code that we have below. Only when we want to continue, we want to continue. That is why we need to put the continue statement inside or checked by a if statement. The continue statement in a while loop will jump back to the test statement. If the condition is true, it will continue with the next iteration. In a for loop, it will jump to the test again and perform the iteration. In this example, we have a for loop with the value of I changing from -2 to +2, and in each iteration, we want to divide 5 by this number. And when the number becomes 0 or I becomes 0, we don't want to divide because that will generate a divide by 0 error. If we execute this code and when the number is equal to 0, the if statement will be true. Therefore, it will get to execute the continue statement and go to the top of the loop without executing the print statement or dividing 5 by 0. When we look at the output, we see that there is no print statement when the number is equal to 0, because the code gets to execute the continue statement and the execution goes back to the control statement. We also have a keyword called pass. Pass does not change the loop execution like the break and the continue, but it can be used to do nothing in a loop. In a loop, we cannot normally have an empty block of code inside a loop. So we can use the pass to write some code with a loop that does nothing. In this example, if you look at, we have a collection of fruit. At the time of writing the code or writing the loop, we do not know what to do with the fruits. So if we put them in an empty block like we have here, what will happen is we will end up getting a syntax error. So how do we avoid this? We can avoid this by using the pass keyword. And when we know what to do inside the loop, in this case, when we know what to do with the fruits in the list of fruits, then we can add the code. But for the moment to execute the code, we can have the pass inside the loop because we cannot have an empty loop or empty block of code for a loop. We can also use the else with both types of loops. With the for loop, the else clause is executed when the loop has finished going through the sequence of iterations given to it. In the while loop, the else clause is executed when the loop condition becomes false. In other words, completing the loop for the while loop. In both cases, this will happen if we do not have a break inside the loop body. In this example, with an else clause, the for loop will be executed until it finds the number 5. If it finds number 5, it will exit the loop with a break and after printing that the number is found. If it does not find the number 5, it will complete the loop and then go to the else clause and then say that the number is not found. If we execute this code, it will take each number from the first and check to see if the number is 5 each time, printing the number. When it finds number 5, it will print that the number is found and break from the loop without going to the else clause. This is because the for loop was not completed. It will only go to the else statement if the for loop is properly completed. And if we print finish and finish the execution for us. Now let us look at the same example without the number 5 in the list. This time the loop will complete, and because it completed without breaking, it will go to the else clause and execute it and print number not found. After that, it will end by printing end. So if we look at a summary of what we have covered, we covered loops in this session. We looked at a for loop and the while loop, and also we looked at what we call nested loops, where we can put loops inside loops. We finally look at the break, the continue, and the pass statements that we can put inside a loop to do things that are slightly different to the normal execution of the loop. We also looked at how we can solve problems using loops by looking at some examples. You should also have the ability to use loops in any other programming language such as JavaScript, Java, or C with some minor changes in the syntax. Hope to see you all in another session of Python coding.
Hello, welcome back to Python for Beginners course. I am Dr. Chaturanga Hettiarachchi, a senior lecturer in Department of Computer Science and Engineering, University of Moratuwa. So today we will be talking about a new topic called functions. So join with me in this lesson and I hope you enjoy it. So I hope you are already familiar with this color code which we will be using to make it easier for you to keep track of most important part of our lessons. Here is a brief outline of this lesson. First, we will try to define what is a function. Then we can try to describe the use of functions in our day-to-day programming activities. You will learn how to invoke or call an existing function within Python programming language. We will try to understand the syntax, use of parameters and return values of a function, which will be greatly helpful for you to create your own functions in Python. First, let's try to understand why we need to define functions. Here is a real-world example. Let's say you want to go from your living room to the kitchen. There are probably 10 to 20 steps. So you can just walk. But what if you have to go to a faraway place? In this scenario, you have to think carefully how many steps you are willing to take to get there. Because walking long journeys can be quite tedious. In this scenario, you can find an alternative. For example, if you are going from Kandy to Colombo, you can just take a bus. Here, you just get in the bus at Kandy and you get off the bus at Colombo. The effort you put into this journey is significantly less. In computer programming also, we get to make such decisions all the time. For example, when you need to display a text message in the computer screen, you can do it by painting pixel by pixel in the screen. Or else you can just call the print function from the standard Python library. If you must paint pixel by pixel from scratch every time when you want to show a message in the screen, it will be prohibitively tedious. If there is any requirement for an update or a change in the output, you must update large number of lines of code. Instead, an alternative is to define the functions to do the repeatable work. When we want to repeat the tasks, it is easy to invoke the existing code via a function call. Using an existing function is as easy as getting in a bus in our real-world example. Print function is an obvious example for this, where print function display a text message in the screen with a minimal effort to the programmer. Now it is clear that as a programmer, you must learn how to use existing functions to easily achieve a task using already written codes. We call this a function call or a function invocation. But it is not sufficient to use already available functions. You must also learn how to build your own functions to simplify repeatable programming tasks. This way, we can reuse a segment of codes to efficiently write complex programs. When a similar task appears repeatedly in different parts of the program, you can frame or arrange that segment of code as a function. For example, if task 1 and task 2 essentially follow the same set of instructions, you can define a function with that common set of instructions. Then you can replace the bulky and repeated segments of the code in main program with just the function invocations, which are just single lines of codes. There can be as many as function invocations as necessary in your program. In that sense, function is a block of organized, reusable code that is used to perform a single related action. Once a segment of code is written as a function, it gives you a better modularity for the program. Also, a higher degree of code reusability even across multiple different programs. I would say defining a function is like designing a bus. Once you have designed and built it once, you can repeatedly use it. On the other hand, calling a function is like riding a bus. It can be easily reused with minimum effort to the programmer. And the function suite can be improved independently from the function calls as far as it is serving the intended purpose. Now let's look at the specifics of each of these aspects with some examples. Invoking an already built function is quite easy if you know the syntax of the function invocation. You can find a list of many built-in functions here in the Python standard library. There are many third-party libraries as well which provide many readily usable functions for various tasks. As an example, print function displays the given message in the screen. Min and max functions are some of the other available built-in functions. Now let us carefully look at this example. Whenever you want to find the largest among a collection of numbers, you can consider using the max function. Simple way to think about functions is that they are machines. Machines perform a process and they can have inputs and outputs as necessary. Some of them does not take inputs when it is started and some does not return an output at the end, but generally all of them execute a certain process. As you can see, all the examples here have a function name and the parentheses. Function name is a name for the process within the machine. And if the machine is working as intended, we can use it repeatedly without the concern of how it is done internally. If there are required inputs for the function, they go within the parentheses here. We call them arguments or parameters. If there's any result or status returned by the function, you can collect it to a separate variable using the equal sign. We will keep the details about how these inputs and outputs should be arranged for the next section, and before that Let's first see how it feels uh, when you are inside the box here, which is the function definition. Now let us take a peek inside the box, which is the function definition. This is how you can code your own function. Every function definition starts with the letters def. Then you can give a name for your new function. It should be sufficiently descriptive but should not overlap with the standard Python keywords such as def or return. Another important part which you cannot miss in the function definition syntax is this colon here. It is there to indicate the beginning of the indented body of the function. Indentation within the function definition is very important. That is how Python identify a particular block of code belong to this function. You can use the tab key in the keyboard for keeping a uniform indentation within the entire body of this function. Usually, function body should be indented at one level right to the indentation level of the def keyword. Then you can write an optional brief description named docstring as a note explaining the purpose of the function. The process of function, which is also named the function suit, goes next. Function usually ends with a return statement. If there is nothing to be returned, you can keep the expression empty. As an example, let us write our own simple function named printMe to print a message in the screen. The function definition starts with the def keyword and the name of the function printMe is unique. One input parameter named str is defined, which will be filled in when the function is called. Notice the indentation of all the function body is at the same level, which is the width of one tab from the def keyword's indentation. And here this is a simple docstring which explains what the function is doing. The function suit of this function is just a call to the built-in print function. It takes in the str as an argument. The function ends with the return statement but without any expression. The return statement without an expression is equivalent to return none. So let us quickly reiterate the syntax of the function definitions. It begins with the def keyword followed by the function name and the parentheses. If there are any input arguments, you can put them inside the parentheses. The body of the function starts with a colon and the body of the function is indented. First statement of the function can be an optional descriptive statement known as the docstring. Then goes the function suit, which contain all the logic and process of this particular function. Finally, the return statement is there and it can have some arguments, or if there are no arguments, it is same as returning none. Here is an example for you to practice. We will define a function to greet a person given a name. If the name is Nimal, it should put hello Nimal in the screen. Let's write the code line by line. First we define the function with def keyword and the function name is greet. There is an argument with the name. Then here's the docstring. Note everything belong to the function definition after the colon here are indented. Then we first print hello, then we can print the name. So this is the function suit. There is nothing to be returned from this function back to the function invoker, so we can just write the return statement with no arguments. Now the function definition is finished. We can go back to the original indentation. Here is just a comment so that we can start calling the function. Here is a one invocation of the greet function with the name Nimal. Then if you want, you can invoke the same function again with a different name. Now we finished writing the code. Let's see the sequence of execution. Function definitions does not belong to the normal execution flow. They need to be invoked in order to execute. So the first statement to be evaluated will be greet Nimal. With the function invocation here, the next statement to be executed will be print hello. After executing print hello, it can execute print name with Nimal in place of the name. So after executing these two statements, it will return back the flow into the end of greet Nimal statement. Now greet Nimal statement also finished executing. The next in the flow is greet Kamal. In this situation, we can again pass back the control back to the greet function. Here again a print hello statement will be executed. After that, print name statement will be executed, but this time the name will be substituted with the name Kamal. After printing the name, it will return back from here to the end of greet Kamal statement. So here is the end of the program. So now can you predict what is the expected output of this program? Here is an exercise for you to try by yourself. Write a program to compute the circumference and area of a circle given its radius. You need to write two functions and use them to calculate and display the result in a screen. The formulas are given here, and here is a hint. R, or radius of the circle, can be passed as an input parameter for the function, and the function return the calculated values. Then you can display them in the screen. So try coding this yourself. I hope now you have some understanding about how to use functions and how to write your own functions. As always, there are a lot more to learn. Try the exercise by yourselves, and I hope you enjoy coding them. Afterwards, you can continue to the next session. Thank you.
Hello, welcome to this lesson on input and output in Python. My name is Buddhika Karunaratna and I am from the University of Morato. This lesson is part of the course Python for Beginners. In this lesson, we will discuss the importance of input and output in Python and how they are done. This is the standard color coding that we will follow in all the presentations. Please take a moment to observe. First of all, let's see why we need input and output. Assume that you open up a video game. If you cannot move your character, or if you cannot see what happens when you move your character, it is not going to be an interesting game. Therefore, no matter how advanced the game is, if you can't interact with it, there is not going to be much fun, and there is not going to be much use of it. Likewise, in order to make use of software, we should be able to interact with it. So that is the basis. Also, the person interacting with it should not always be a human. It can be another piece of software in another computer. We use the notation I/O, pronounced as IO, to convey the same idea, that is input and output. To get input from the user, we can use built-in functions available in Python. So by this time, you are aware of what a built-in function is in Python. The function input takes a user input from the console. If you want to provide more information, as an example, what the user need to input, we can include a prompt inside the brackets, but this is optional. Here we have an example. When we execute this code segment, we can see that our prompt gets printed and the program pauses till the user enters something, or in other words, inputs something. For example, if I enter my name and press enter, it will display my name in a new line. In Python 3, the default type of input is string. So no matter what you type on the console and enter, Python will get it as a string. Python will see it as a string. So what if we want the user to input a number? For example, their age, which is obviously a numerical value, a number. For that, we have to convert the variable to our desired type manually. How do we do that? We can do that using methods such as int, which is a built-in function. And that method will convert the variable to an integer. Now let's see an example. Like previously, when we press enter, Python will store the input 25 as a string in the variable named x. If we check its type, you can see it is a string. But we want this to be an integer. So what we can do is, we can explicitly convert the value stored in the variable x to an integer by calling the function int, which is a built-in function. Now, if we check, we can see that x is an integer. The conversion has been done. Now let's see how we can display something on the screen using Python. For this, we will use a built-in method named print. By now, I believe you are quite familiar with this method already. This print statement, you have been using it for a number of examples up until now. So this print function will display whatever the required output. What we have to do is, we can simply pass the variable or the value we want to print inside the brackets, and the method will display it on the console. Here are some examples. You can see how we use print statement to print a string and an integer. All right, now what if you want to print multiple variables at the same time? Writing a print command or a print statement for each one is going to be a tedious task. We can simply print them together in line by including them separated by commas inside the print method. If you are observant, you should have probably noticed the additional space between the variables when they were printed. This is known as the separator. We can change this to any symbol we like by passing in a value for the SEP argument. If you put a dash, the variables will be separated by a dash. We can also add a special symbol at the end of the line by passing a value for the END or end argument. Now, if we want to make our output more presentable, nicer, by formatting it according to a template, we can make use of the string formatting methods available in Python. We can use curly braces as placeholders in the template and use the method format to fill those placeholders with the relevant variables. We can also specify the order in which the braces should be filled. Since Python is 0 indexed, 1 is the second variable and 0 is the first variable. You can see that in the values have been switched in this scenario. That brings us to the end of this lesson on input and output in Python. We will see you in another lesson. Thank you.
Hello everyone. Under this section, we will look into strings in Python, one of the popular data types used in Python. During the section of variable and data types, we had a brief discussion on string data type and the immutability of Python strings. Let's find out more in detail about string and string operations in Python program. This is the standard color code we will be using throughout this lesson. Please take a moment and have a look. Strings are commonly used in Python programming. In fact, strings are the most common popular data type in Python. A string is a set of characters. When we want to declare a string, we can use characters or set of characters within a single quotation or a double quotation, which Python accepts. As an example, the following two examples create two new strings and assign them to variables, namely var1 and var2. When we consider string operations, concatenation and repetition could be done with plus and asterisk symbols. If we want to concatenate two string literals and create a new string, we can place plus symbol between two string literals. To repeat a string certain number of times and create a string, you can use asterisk sign followed by number of times you intend to repeat that string. Also, Python has another way of concatenation. If we place two string literals next to each other, those will be concatenated. But this would not work with arbitrary string expressions. Like other programming languages, Python does not have character data types. A single character is also considered as a string of length 1. Character in a string also considered as a substring. To access individual characters in a string, we can use square bracket operation with the index. The slice notation or the square bracket operation with two indices separated by a colon could be used to specify substrings of a string. As an example, let's create a string with the concatenation operator and assign it to the variable word. If we try to access the character at index 4, it will return fifth character in the string since the index starts with 0. If we consider the substring specified by the slice notation within square bracket 2 colon 2, the substring between indices 0 and 2 will be retrieved, excluding the character at index 2. Note that when using slice notation, it is expected that the ranges specified by the two indices will exclude the character in the second index of that range. As an example, if you access the substring between the index range 2 to 4, this will return a substring containing characters at index 2 and 3, except the character at index 4. Let's talk about defaults in slice notation and consider the same string created in the previous case. If we try to use square bracket operation with index as -1, it will return the last character of the string. With the index as -2, the square bracket operation will return the character before the last character. If we use slice notation with -2 as the first index without specifying the second index, this will return the last two characters of the string as a substring. Furthermore, if we use the slice notation with -2 as the second index without specifying the first index, this will return everything except last two characters of the string as a substring. Can we update the content of a string? As we discussed under the section of variable and data types, strings are immutable or cannot be changed once created. Also, if we try to assign a new value to a variable holding a new string object will be created with a new value, and the identity would also be changed. Furthermore, if we try to change the value of a string object using square bracket operator, it will throw a type error as strings are immutable objects. In this case, a new object will not be created. Since strings are immutable, instead of updating the strings, we can create the required strings as a new object as used. To do so, we can use operators specified for the strings. If we consider the same string assigned to the variable word in the previous cases, to change the first character of the string, we can create a new string based on the concatenation operator, concatenating the required first character for the new string and the rest from the string we considered. If we want to update all characters of the string except the last one, we can create a new string based on the concatenation operator, concatenating the last character of the string we consider and the rest as the string as required. Let's try to understand the immutability of strings, especially while trying to update a string. Here I have created a string object with the value pqr and have assigned it to a variable str1. The variable str1 has been assigned to a new variable str2. You can retrieve the value of the variable str2, which validates the assigned value to the variable str1 is correctly assigned to the variable str2. Furthermore, if we try to change the value of a string object using square bracket operator, it will throw an type error as strings are immutable objects in case a new object will not be created. Let's try to understand the mutability of strings furthermore. The variable str1 is assigned with the value str1, and here I have assigned a new value xyz to str1, and retrieving the value of str1 validates the assignment. Variable str2 still holds the value pqr as we assign the value of str1 to str2. Also, the str2 is assigned to a new variable a, which has the same value as str2. As we know, if we check the identity of the variables using id function in Python, it will return a memory address, which is an integer. The identity of a and str2 is the same, while the identity of str1 has changed. This means changing the value of str1 has created a new string, while The identity of other variable assignments do not change since the string assigned to the same have not been mutated. Another useful property of a string is the length. We can use built-in length function to retrieve the length of a string. As an example, we can consider string hello, which has length of 5. To retrieve length of string hello, we can use the function length within brackets variable name a, which will return 5, which is exactly the length of the string. Let's discuss the summary of the string operators discussed under this section. Let's have two strings hello assigned to variable a and Python assigned to variable b. As we know, plus or the concatenation operator adds the string values on either side of the operator. As an example, a plus b will return hello Python without any spaces in between. The asterisk or the repetition operator repeats or creates a new string concatenated multiple copies of the same string. As an example, a asterisk 2 will return hello hello without any spaces in between. We also discuss the square bracket operator or the slice operator, where we can access characters of a string given an index. A within square brackets 1 will return the character at index 1 of the variable a, which is the character e. The range slice notation could be used to retrieve substrings or a set of characters from a given range. If we want to retrieve substring of a variable a given the range 1 to 4, we can use notation a square bracket 1 colon 4, which will return ELL, the substring between indices 1 to 4, except the character at index 4. Furthermore, there exists a useful operator, namely membership operator. We can use this operator to check whether a certain substring or a character is included in a given string. If we check whether letter H is in variable A, it will return true. The not in operator is the same as the previous case, except it will return true if a character does not exist in a given string. If we check whether letter M is not in variable A, it will return true. We have reached the end of this lesson. In next lesson, you will get to know about libraries in Python. Happy learning.